Hello, Algebra 2. Let's get going. What is the remainder in the division? You can use long division or you can use synthetic division. I'm going to use synthetic division. Since we're dividing by x minus 4, I'm going to put a positive 4 in the little box. And now I put the coefficients. It's missing an x squared term, so I've got to fill that in with a 0. 70, negative 120. We drop down the first one, and now we multiply. 4 times negative 4 is negative 16, and then we add. 0 plus negative 16 is negative 16. 4 times negative 16 is negative 64. 70 minus 64 is 6, and 4 times 6 is 24. That would be negative 96. So this question said, what is the remainder? So negative 96 is our answer. If you have to put it back, if you have to answer, divide, what's the answer? You would turn this back into a polynomial. So we're x to the third divided by x. So our quotient here, quotient is the answer to division, is going to be a squaring. X to the third divided by x is x squared. So it'd be negative 4x squared minus 16x plus 6. And then when you have a remainder, you put plus, and then the remainder on top, and x minus 4 is your denominator there. So this would be the answer to, if the problem just said divide this divided by this, then this guy would be your answer. But this particular problem just said what is the remainder, so we answer negative 96. Use synthetic or long division to find the quotient. Since I did synthetic in that one, I'll do long division in this one. X minus 5 is going into 3x squared minus 7x plus 16. There were no missing terms. X times 3x is 3x squared. 3x times negative 5 is negative 15x. And then remember, draw the line, switch the signs, because you have to subtract. Subtract 3x squared, subtract negative 15x is adding. That adds to 0. Negative 7x plus 15x is 8x. Drop down our next term, and we're going to start again. X times 8 is 8x. 8 times negative 5 is negative 40. Draw the line. Switch the signs. 16 plus 40 is 56. So it does have a remainder, plus 56 over x minus 5. That is the quotient, the answer to division. Given x minus 5 is a factor of that polynomial, find the remaining factors. So it's telling us that x minus 5 is a factor. So I'm going to find the other factor, the quotient. 1x to the third, 4x squared, negative 31x minus 20. And drop that guy down. 5 times 1 is 5. 4 plus 5 is 9. 5 times 9 is 45. Negative 31 plus 45 is 14. 5 times 14 is, I'm on the wrong one. This is weird because my, I just I already wrote out the answers here. And on mine, on the one that I'm looking at, which is your guys's, it says that this is a 70. X to the third plus 4x squared minus 31x minus 70. So I don't know how this one got messed up. So I apologize for that. So yours should say this. So I'm going to change that to negative 70. 5 times 14 is 70. So we don't have a remainder. So this guy factors into x minus 5 times 1x squared plus 9x plus 14. It says find the remaining factors. So that means that that guy is going to factor even further. X minus 5, and that is just a regular quadratic trinomial, the easy kind. So I need two numbers that multiply to 14, add to 9. So it'll be x plus 7, x plus 2. It's weird that my copy was messed up like that. I hope. Now the other ones are, and I'm going to watch, I don't know how much time it's been. I'm just probably going to make this video in parts. Graph the polynomial. Okay, so this is in factored form. It's not multiplied out. So that tells us the roots. That means it's crossing the x-axis through 0, negative 3, and positive 1. Negative 3, 0, and positive 1. X times x times x. It's a cubic function if it was all multiplied out. And so that means the leading coefficient is positive and the exponent is odd. So if you remember your end behavior, positive odd means it's up to the right and down to the left, and then whatever's happening in the middle. So clearly this is going to have this kind of a shape, but to graph it accurately we have to put it in our graphing calculators. So I know that's going down and that's going up, but where are those points? So I popped it in the graphing calculator, which yes, you can use that on the final. And once you type it in and graph it, you press G-solve, and then you can hit maximum and it'll tell you that, and then hit minimum and it'll tell you that. So the max came out to be negative 1.9, 6.1, and the local minimum is 0.5, negative 0.9. So to the left, almost 2, up to 6. And the minimum is over a half and down almost 1. So now we can throw those curves in there. Boom. She's graphed. What is the end behavior for the function? So like up here, this was in factored form, but I did the x's to figure out what that leading coefficient would be. So this would be x to the third times 4x to the fifth for a leading coefficient 4x to the eighth. I don't have to actually multiply all this out. That would take a while, and it's not necessary just to talk about the end behavior. So our leading coefficient is positive, and we have an even exponent. Even means both the arrows are going in the same direction, either down or up. Since it's positive 4, that means we're going up. So the way end behavior is written, as x approaches positive infinity, means as you go to the right, f of x, the graph, As you go to the right, as you go to the right, the graph is going up, so it's approaching positive infinity. Then as you go to the left, as x approaches negative infinity, the graph is approaching positive infinity. Number 6, solve. Okay, looks like we could factor out an m. 2m squared minus 5m minus 7. And this guy is a quadratic trinomial, the harder kind because we have an a value bigger than 1. So we're going to go a times c is negative 14, and our middle term is negative 5. So two numbers that multiply to negative 14 add to negative 5 would be a negative 7 and a positive 2. So you can do factor by grouping, or you can do the box method. Everybody seemed to like the box method. First term, 2m squared, goes top left. Last term, negative 7, goes bottom right. And then I'm going to fill in the other two boxes with these guys to replace the negative 5m. And it doesn't matter which box. Negative 7m and 2m. Now I'm going to factor. Take a GCF out here. We can take out an m. So then m times what is 2m squared? That'd be 2m. M times what is negative 7m? That'd be a negative 7. And then 2m times what is 2m? That would be a positive 1. So then our binomials are here. So we've got our m in front, 2m minus 7, and m plus 1. And I'm just going to always double check your work. If you FOIL this, you should get this. So 2m squared, check. 2m minus 7m is negative 5m, check. And negative 7 times 1 is negative 7. So we're good. So m equals 0, 2m minus 7 equals 0, and m plus 1 equals 0. So m is 0, 7 halves, add the 7, divide the 2, and negative 1. All right. Translate the graph of f of x equals 1 over x, 3 units down and 4 units to the right. Write the new function after the translation. So this was chapter 4, rationals. I can't remember if it was a 4, but it was the rational chapter. And if you remember, the graphing form of it was, I can't remember what letter they used above for the 1. So you'll have a constant and then x minus h plus k. So, and it did the opposite and the same for our movements. So f of x is equal to 1 over, h is your left and right. So 4 units right, that'd be x minus 4. And then down 3 units would be a minus 3. Identify the asymptotes, domain, and range of the function. All right, so this is in that form. Here's my grid. We are going to the right 4. So the vertical asymptote is x equals 4. And we're going down 2. So the horizontal asymptote is y equals negative 2. And then the domain and the range, it's a positive 3. So our branches are going to be top right and bottom left. And so our domain is where's the graph from left to right. On the left, it's going forever. On the right, it's going forever. But right here, it skips over the x equals 4. So our domain, x such that x is, or we could write it like this, x is all real numbers except 4. And then our range is bottom to top. It's going down forever, up forever, but it's skipping over the horizontal asymptote. Y such that y is all real numbers except -2. Write an equivalent form. Okay, so this is a rational function, and it's a fraction, so which means it's a fraction. And as you guys know, fractions are really division. So this problem is saying 3x plus 2 divided by x minus 2. So I'm going to perform the division, and what that does is puts it in the graphing form. So it'll look like this guy. X times 3 is 3x. 3 times -2 is -6. Draw the line, switch the signs. That adds to 0. 2 plus 6 is 8. So that's our remainder because it's the last term. So plus 8 over x minus 2. So then for it to look normal, we would switch those around. I'm going to put the 8 over x minus 2 and the positive 3 second. And so now you'll see it's in that graphing form. So we would know the vertical asymptote and the horizontal asymptote from that. Number 10, and this will be the last one for this video, part 1. Graph below, make sure to identify any vertical and horizontal asymptotes with dashed lines. So this one is in the form like number 9, so I'm going to do that same thing using the division, so I can just go ahead and put it in graphing form. X times 4 is 4x. 4 times 2 is 8. Draw the line, switch the signs. That adds to 0. 1 minus 8 is -7. So plus -7 over x plus 2. So our function rewritten, -7 over x plus 2 plus 4. So that means we have a vertical asymptote at x equals -2. Where am I? Vertical asymptote. And we have a horizontal asymptote at y equals 4. And now the branches. Our top number is negative, so that means it's going to be here and here. But what I want to do is put this in the graphing calculator so I can get those points. I could plug numbers in here and do the math, but like we can use the graphing calculator, so why not make our lives easier? And I did that already, and we had a point at -8 just above that marker. Then we had 2 over, it was there, and then we had -4 up to 7.5. I think. Yep, about that. So our left branch, and I can't remember if I said this or not, but the top number is negative, so that means they go top left and bottom right. Where if it's positive, you're top right and bottom left. And then this branch, we have over 1 up almost to 2, over 2 up about 2.5, over 4 up to 3. Probably, oh, sorry. I had another point on there. It was -1, -3. There we go. Make sure to identify, okay, we did that. Okay, we're good. That's it for this video, part 1. And it was 20 minutes. That's not bad.